Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says Stickler thief. The problem is pretty simple, and we are provided an array. Let's get step by step. So we have a friend, Stickler, the thief, who wants to loot a money from the houses arranged in a line. He cannot loot two consecutive houses and aims to maximize the total loot. And in this process we are given an array ARR where ARR of I represents the amount of money in ith house, and we need to determine the maximum loot he can. The problem is good, it's simple, but there's a catch over it. So we are asked to say that no consecutive house robbery is possible. So no consecutive house to be chosen. So if I chose 1, then I should choose 3, or if I chose 2, I should be chosen 4. In short, if I chose I, if took I, then take I plus 2. That is the case we need to follow, and if this is going ahead, we are good to go. And objective to maximize the loot. Well, so it's typical case of one of the very famous method of solving the questions, but I will not go ahead and directly jump out. But as you can see, this topic is very famous and it has been asked in many company tags. So we'll approach this problem. So how do we solve this? So we see we have an array like this, and we choose to go ahead and use 6. I will say that hey, rob from house 6. Then you say okay, I'll rob from house 6, and I'll just take the total amount. Here is the total loot. Now I'll say if I'm robbing from house 6, then I would go rob from 5, not the immediate 5 but the next 5. House 6 which was at index 0, and house 5 which is at index 2, because 0 plus 2, as we said, if we took I, we need to take I plus 2, and if I'm doing that, it will give me something like 6 plus 5, it's 11, and that is our total. Now if I've chosen 5 to go with, then I'll go and choose 4, rob from 4, which is at index 0, 1, 2, 3, 4. Okay, it's at index 4. Coincidence. So 15. So that is our total. Else we can go ahead and do another set of combinations that we skip 0th house and we rob from 5 with index 1, and which gives us a total of 5. Wait for a while, this might not seem very good because in earlier case we had 6 as a total, but now we are having 5 as a total. So it's a taking of 0th house, and it's something like not taking of 0th house. Wait for a while, hold on, and if I'm not taking 0, I'm taking 1, then next time I should take rob from 1 plus 2 is 3, and at index 3 we have 7. Then we have 7 plus 5 is 14, I guess. No, okay, I'm sorry, 12. It says a total. In this case that might not work, but here if I say it's not 5, it's 10, the entire game changes for a while. So if it's not 5, it's 10, it's 10 over here, and it's 70. So maximum robbery we got is not by taking this, but by ignoring this and taking 10. So how do we check this? The one way to do is to consider taking and not taking. So cool, then if we are going ahead with taking and not taking, let's code in this way and see what can happen. First of all, I will go ahead and say hey, I'm taking this thing, I'll just go ahead and use the util method. This method name is very ambiguous, I understand that, but bear me with while this method name is going to change and it will make sense. So 0, because we are starting from 0th house, and we are going to private int util. I'm taking an array a and index I. Obviously I wanted to do an check if it is greater than or equal to a dot length. Then I'm going to say, hey, you have given an invalid index. Okay, so you will get 0 rupees or 0 amount of robbery money. But we have to consider this taking and not taking thing in consideration. So if I say that I wanted to take this thing, else I wanted to not take this thing. So how do I define take this thing? So I'll say rob this. I'll say taking means nothing but robbing the current house. So from the house, I'm robbing the current house, and I'll take the amount as a of I, and I will rob the I plus 1th house, I plus 2th house, sorry. If I'm taking I should check for I plus 2. So here is I plus 2. And if I'm not taking this, then I can just simply ignore, and I'll say, yeah, I'm not taking, so 0 plus, because nothing is being looted. 0 plus rob a comma I plus 1. Why 1? Because I'm not taking this one, right? So I can jump immediately forward. So if I'm not taking 6, I can go with 10. So if I'm not taking 10, I can go with 5. In that way. And ultimately what I do is return mat.max of take and not take. Sweet. Let's run this. It would pass the sample test cases, obviously. Yes. But hold on for a while. It would fail drastically in the rest of test cases. Let me execute this problem. So I'm executing this and it would fail. Why it would fail? Many of you might have an answer ready for this, because we are having a complexity which is exponential. So it handily bears 10 cases, handily passes them, and since the time complexity is exponential and we are doing many repeated tasks and things are happening again and again, what can we do? There's something known as a cache. We will implement this, a new int of arr.length of int cache. So what this cache does is, you see, we were doing a repeated amount of tasks, and hence our time complexity would go to O of 2 to power n. Why 2? Because we have two options, whether to take it or not take it. Now, why we are doing things twice? Twice in the sense, if I'm not choosing 6, and I'll say I will not choose 10 as well, then I'm not choosing 10, okay. So, but if I'm choosing 6, I will anyway not choose 10. So there are 2 times I'm not choosing 10. Can I do something for this? Yes, I can do it, and I will introduce a cache over here, and I will say that, hey, cache of I would store the maximum amount which can be robbed till the ith house, which means that instead of returning, I'll just say cache of I is equal to this, and I'll return cache of I, and instead of double counting it, I'll just check if cache of I is not equal to 0. If it is not equal to 0, it contains some value. It means we have already computed it. So return the computed value which is stored in the cache. Let's run this thing. Okay, we have few errors over here, which means 63. What is the error? Okay, we need to include the cache as well. Cache. Since the method signature, I have not updated it over here. So yeah, it has ran successfully, and let's check for rest of the test cases. This has drastically reduced our time complexity, and now the time complexity is O of Okay, it has passed test of the test cases. Now the time complexity is O of n. But hold on for a while, because this, my friends, is not the only solution for solving this problem. You see, we introduced the cache and we solved this problem. But there is another way. We, however, used here recursive method, which would internally consume stack trace, and it consists a new auxiliary space. So space complexity is O of n plus the stack trace or stack space, whatever you wanted to say. But can we remove this? Yes, I'll say instead of doing that, I'll just introduce cache new int a. I'll just remove this name, and this sounds very weird. Or I'll just use return rob with arr, and that's it. Here I'm not going to iterate anything, I'm not going to recurse anything, but I would go and iterate things. So how would I be doing this? Let's see. Int a, and what I'll see is int if a dot length is equal to 0 or 1, return a of 0. Else we can go ahead and say int cache is equal to new int of a dot length. Initially we have two houses, you see, this and this. So initially, if I'm saying that the same slogan which we have mentioned earlier, that cache of I would store the maximum amount which can be robbed till the ith house. So I'm asking you, I'm at I house 0, which means cache 0. What would be the amount? So you would say bluntly that, hey, it would be the amount as a of 0, because we have only one house, and how many houses we can rob? Only one. Okay, now tell me about if we have I is equal to 1. Okay, you would say a of I is equal to 1, but that would be wrong, my friend, because sometimes it might happen it's not 610, it is 6010. You can consider first and second both the houses. Now here I wanted to compare both a of 0 with a of 1. Math.max. And what about I is equal to 3? Okay, we are not going to do it again and again. I is equal to 3, 4, 5 and so on. Let's use for loop. I is equal to 2, I is less than a dot length and I plus plus. See, we have two values and we are going from this. Now see, we wanted to take this ith element. So if I'm taking this ith element, I wanted to consider I minus 2th house. So I wanted to consider I minus 2 house which is not just next to u. That means I minus 2. So I'm I minus 2 plus current house price, which is a of I. And if it is not take, it is cache of I minus 1 plus 0, since not taking 0, because we are not taking anything over here. And ultimately what do? We store it in the ith value. Because why? Because cache of I would store the maximum amount which can be robbed till the ith house. Okay, how many times I have said this? Maybe 3 or 4 times. Okay, I'm taking this, I'm not taking this. And ultimately we'll have our answer within the last house that what we wanted, a dot length minus 1. And let's see whether it works or not. You see, we have reduced the stack trace by a drastical amount by just iterating it and not by not recursively approaching it. Anyways, time complexity remains the same. The only matter is the space complexity where it fits in, and that too in the recursive space complexity. It has passed all the test cases, but can we do again? Can we do bit more? Okay, of course we can do bit more. Why? Because we only want last 2 items. So why are we storing all the items? This is a point to think, right? We want cache of I minus 1 and cache of I minus 2. So if we want only 2 items, why we are storing all these items? And we can reduce this entire array to just two variables, which can be previous and which can be next. But I will not solve this, and this can be exercise. And I'll see you in the next one. By the way, this topic is known as dynamic programming, where you can see in the topic section, it's a dynamic programming. And for more such dynamic programming concepts and videos, click the video on your right, and I'll see you in the next one.